Hello everyone. Today it's going to be about Viv Flagger. I'm super excited about this because it's a very new tool and it's very promising. Just looking at a few GitHub README files, I think it's going to be a super nice one. But I'd like to start with the tweet. It came out 2 days ago, which defines Flagger in a very concise way, which is absolutely correct, although probably a bit cryptic for people not doing this every day. So here is the tweet. Flagger implements a control loop that gradually shifts traffic to the Canary while measuring key performance indicators. Okay, so what is this? So Flagger is a deployment tool. Canary, blue, green, and other tactics or strategies. And what it essentially it's a control loop. It's basically from control theory. So control loop is basically an endless loop which checks events, and if it realizes that it has to do something, then it tries to correct its target environment. So basically the implementation is a Kubernetes operator, which is like basically an event handler, nothing else. It constantly receives update, delete, created events on PodServices, whatnot, basically what you subscribe for. And if it sees the right entity being created, deleted, or something, and it doesn't fit into the world as it should be according to Flagger, it's going to take action. So basically it's gonna shift traffic to the Canary while measuring basically maybe like a Prometheus metric or something else. So it's perfect for implementing blue, green, or Canary or something. And this link goes to Vworks, the web page. It's probably a very nice web page. I'm not going to go through this, but instead I'm going to go GitHub and then look at the actual thing. Yeah, progressive delivery Kubernetes operator, Canary, A/B testing, blue, green deployments. It has a docs page, but for now let's stick to this README file. Now with Flux, this diagram tricked me, but maybe this time this is more clearer. So user hits the ingress, either gets routed to the primary service or the Canary deployment, or the Canary service behind there is the deployment. And basically Flagger is looking at Kubernetes, the Kubernetes API, checks different values and Prometheus as well, and then adjusts this routing. And as I can see, it will notify you over Slack. That's fine. And it doesn't implement the Canary deployments itself. It tries to build upon different other tools, mostly service meshes like Istio, Linkerd, and so on. But I remember, or as far as I looked at the documentation, that it can handle the nginx ingress as well. Later versions has support for Canary. That would be my target backend because I'm not too comfortable yet with service meshes. So let's see how it goes. I'm trying to set up probably an nginx based Canary deployment in this video. So what do we have here? There is the installation guides. I'm gonna click those very soon. I'm gonna use it on Kubernetes, K3s as usual. Yeah, how it works. Canary custom resource. I suppose this is a YAML file. Yes, a large one it seems, but it's the usual Kubernetes definitions, provider Istio, target, progress deadline, service, what service to scale. Yeah, so schedule interval every 60 seconds. This is the rollback threshold. How much traffic we should send to the Canary. Increase by 5s. by 5% each time. And the metric we should look at is request success rate. We should have at least 99% success. And this one is, I don't know what's this. And then probably this is like something like a smoke test, but let's get here later. All right, so this is what I expected here. Basically with this you define the strategy which you are going to use to deploy, and then this control loop, basically flagger, is going to enforce that over your deployment. I don't know yet how we will trigger the deployment, maybe with a CRD, like a custom resource definition, maybe not, but I think we will get there. Yeah, these are probably not important right now. Okay. Yeah, we just seen this. Features. Oh yes, nginx is supported. I'm happy about that. With almost all features. Not with traffic policy and other things, because nginx doesn't know about that. It doesn't control the network between the services. But other than that, it supports everything that I need. All right, it will be integrated with other controller, other ingresses like HAProxy ingress. That's very nice. I tend to use the most simple product out there, and nginx, HAProxy, I like those. Oh, this is nice. So the metrics will not be static, like defined in the YAML, like it has to be 99% error rate, but compared to the primary deployment. So basically we can just say like, hey, make this metric not worse than the primary deployment. That's cool. Apache 2. All right. This looks simple enough. So installation. Can we just use the markdown files? Maybe there is an install or docs folder here. Docs. No, there is no. All right, I'm gonna use the documentation page. That's fine. It's a bit too large. I don't know what are these admission controllers, but I hope I can just use just a vanilla installation of any Kubernetes. Okay, there's a Helm installation, and can I just use a kubectl apply or something? With Kustomize. Okay, I never use Kustomize. This is the new kid on the block to basically template YAML files. Okay, I think I'm gonna make a try with Kustomize if there is no vanilla kubectl apply. Kustomize and nothing else. All right, then I have to do Kustomize. So this one is for Istio. Maybe there are other things right there. But first things first, let's have a Kubernetes cluster running. So I'm gonna create a folder here, flagger. Oh, come on. And like usual, I'm gonna use a Docker Compose file from the K3S project which is like a lightweight Kubernetes. I use this instead of Minikube. And the GitHub page. Compose, row, copy everything, and this is going to be okay. This will start up 2 containers, the server and Kubernetes node, and it will map out the config YAML to the current folder, which is going to be my, yes, the dot, which is the same folder as the Docker Compose file. So I'm going to just Docker Compose up in the background. This should just work. And I'm going to list the files. Yes, we have the YAML here, and here I'm going to utilize this YAML file, and K is an alias for kubectl for me. Okay, so we have a Kubernetes node running for 17 seconds now, and I'm gonna watch kubectl get pods all namespaces. This is just the usual drill. Here I also have to export the kubeconfig. Okay, these are the system pods. All right, customize. So I'm gonna go vworks flagger, customize istio. So there is a customize folder. Yes, customize. Istio, base, Kubernetes, Linkerd. So how do I install it for nginx? Oh, but I need an Ingress Controller as well. So let's see, nginx Ingress. Live docs. All right, the mandatory things. Before applying, let's just look at this file, but I think it's going to be namespaces, service accounts, RBAC roles, namespace in nginx ingress, config map, an RBAC role. Yeah, just the usual stuff. And the deployment as well, probably for the default backend, and this one for the Ingress Controller. And the version is 0.25. Nginx Ingress Canary support. This is nice. I'm gonna look at this, but I just want to see which version started supporting. Yeah, 22. In practice, this is how we do a Canary, just without any flagger, just with the Ingress Controller. We have 2 deployments, and we have two ingress definitions. Okay, so it's the ingress definition that defines the canary values, I suppose, here. Yeah, okay. So ingress 2 is the canary with a weight 10. I suppose it's 10%, and it routes here. And ingress 1 will be just a normal ingress. Yes, there are no canary here. Okay, so it's very simple just to do canary manually. Just deploy another ingress and manually increase this number, or scripted way, like in a bash script. And once you are done, I suppose v2 is going to be in place. So basically without Flagger and any complexity, you can just make a canary deployment with the nginx ingress just with a very few commands in the bash script. So this is not rocket science what we are doing. There is support in the underlying infrastructure already, but Flagger's declarative approach to not vworks but Flagger declarative approach to the canary and blue-green and so on is very nice. So I think deployment strategy deserves this YAML configuration and the kind of configurations or advanced logic what we can place in here. It's worthwhile to try to use Flagger because it's implementation agnostic. So you could switch out Istio for Linkerd and vice versa. Not that it will happen in any company like ever. So this portability is usually just something we comfort our minds with. But still, I think this is a better structured way than just a makeshift bash file, which will evolve in weird ways over time. So that's that. Back to... All right, I'm gonna close the nginx ingress. This one we should apply. I went on a detour. So here kube config, not the remote one, but Flagger kube config. That's good. And I'm going to apply the mandatory one. Bunch of things created. Also the Ingress Controller is being created. That's good. Provider specific steps. We don't use any of these. I think I need a Nodeport because my installation counts as a bare metal one here. Yes, I think, what does it do? I think this one just exposes the nginx service as a Nodeport, or creates the service. Exactly. So if I apply this guy, apply this, then the previously created ingress is going to be exposed as a service. So get svc all namespaces, and I have I make the font size once smaller maybe. Okay, so this is my ingress. So I just need probably a domain name or just my localhost IP. Nothing. Maybe it's Okay, I am tricked with this in every recording. So what do we have here? We have two Docker containers. Okay, because that makes a lot of sense. So I can access the Kubernetes API if I do telnet. Because the container maps this port out. Yes, but my pod, even though it listens on this Nodeport is only available inside this server container. So how about I map it out? Two things, not just one thing I have to do for this. I'm going to map out, and I could even make this nicer. I could just map it to 8080, but let's not risk things not working right now. So since it's using a volume, okay, so it's using a volume. So if I just stop the compose, it's still going to be available, and I just need to restart. Fingers crossed here. That's the beauty of a recording. PS, okay, the port is mapped, and if I do this again, I think it's fine if I just no, the connection was reset. Okay, but something is running there, or no, it's maybe the so first of all, I should run this in the background. I'm going to just check things from within the container. Do I have things? Curl, telnet. Oh, I have telnet. That's unexpected, but I'm happy for it. And the port was interesting. So okay, so it's maybe not the server, it's the node. Okay, yeah, of course. I'm gonna do the same exercise for the Kubernetes node, because that is where the nginx container is running. So maybe I just go all in and map this guy. We don't need this one, but need this one. And I'm going to do a kubectl or compose down and compose up. And crossing my fingers again. Oh, port is already allocated. Ah, yes, here. One more time. Okay. Do I understand container networking or not? No, I don't, clearly. So let's exec to this guy. That is annoying. I'm gonna do a few more checks, and I might cut the video here, but I think it's worthwhile doing these debugs because it's just every day. Alright, the solution was quite similar like last time. I ended up just forwarding the port out of the container. Somehow, so K3s is running in a Docker container, and somehow the Nodeport did not bind on all the network interfaces, or something similar happened, just like last time. So this is this issue is haunting me, but the port forward seems to work. There was one more interesting thing, that K3s has a traffic load balancer, traffic Ingress Controller running as a load balancer type service, and it has an external IP. I believe this is just wired in hack, which doesn't apply to me. So I tried creating a load balancer. It had a pending external IP, basically what I expected, but the Nodeport was not working. So I'm just forwarding the deployment directly to my localhost 8080, and there was this K3s issue which was helping me along the way, although it didn't help after all. But I found a nice hack, because Ingress controllers in Kubernetes work based on host names, and I typically set the host file to some random domain, but it's just a header, it turns out, what the browser sends. So I could just use this in the future, or I will change my host file in 5 minutes. But let's see how I'm going to set this up. So this localhost port 8080 now returns 404 not found. I think this is my deployment. Should I, if I stop the forwarding, this should not work. Yes, if I start the forwarding, this should work. Alrighty, I think I'm going to need a deployment too. So I think this search will give me just a simple YAML deployment, a service. So let's just make this work, or deploy this. Flagger code, and save it as a deployment, or service.yaml. It's an nginx deployment with 2 replicas, and I'm going to need a service here and an ingress as well. So how about I do another search, Kubernetes ingress example. Okay, let's take this block, or Okay, so PodService Ingress up. Let's just go to the official page. Okay, so this is the ingress, a path-based ingress. I prefer host-based ingresses. I'm not sure why, just for fun. So this is an ingress, name, a service, I'm always in trouble with these labels. fubar.com will be our host name. Service port 80. This is a super old nginx, but this will be fine. And I also need a service with cluster IP. So Kubernetes service cluster IP example. Defining a service. It's not called my service, but a service. This selector is a target port. I don't know about these, but I think it should be 80. Okay, so how about I am deploying this as is and see what happens. So kubectl apply -f a service. All right, the pods are starting up. We have cluster IP, and we will also have an ingress. There we go. We have an ingress. So if I use this trick and access my and it's fubar.com. Yes, okay, so basically I accessed it over fubar.com, which is just a fake domain, and on this address, if I do it like here, it won't work, but I will make this fubar.com point sudo vi my host file, and I'm going to and if I go fubar.com port 8080, welcome to nginx. Good, so this is my deployment. These are not needed anymore. I have an nginx running. It was a bit of a detour, but next step, customize for Istio. Again, I saw nothing for the nginx. Customize // what's wrong here? Customize Istio Generic. Great. I'm going to use just this. What's a mesh provider? Kubernetes. Oh, great. Okay, the generic installer was not part of this. No generic installer. No, this is how it works. This is the installation. So how about generic? Oh, yes, great. I wonder why people repackage their GitHub markdowns as this. It's a Gitbook. Okay, I'm gonna look at Gitbook. Just a later point. All right, let's run this. Namespace, CRD, okay. Service account, RBAC roles, a Prometheus. Okay, so a Flagger was deployed, which is the controller, and the Prometheus was deployed just to have something to play with. That's great. How about services? And there is a Prometheus. I'm going to look at the Prometheus just in a moment. And there is this Flagger. So this is basically what does everything. I'm interested what's inside the logs. Great, this is just a controller. Looping and looping until eternity. Okie dokie. So Prometheus. This is just how Kustomize works. I don't care about that right now. Flagger, Prometheus. Okay, so again, get the services. Get the ingresses. Only it's a cluster IP, so I could expose this with an ingress, or I could just forward. Let's just forward, keep it simple. Oh, my bash initialize is quite slow these days. Something is blocking it. Flagger system port forward. Prometheus, or no, the service. Let's port forward the service. Port 1990. 1990 is fine on my local as well. I forgot setting the kubeconfig. This is not a pod, this is a service, so maybe service slash. Ah, sorry. Good. Okay. Goody, I like this one. What metrics or what targets are there? Kubernetes and upmesh envoy. Not for me. All right, so I think I have a flagger installed. Close this guy, close the Twitter page. What next? What now? Close this guy. nginx Canary deployments. Yes, we have to use 0.24 or later. We have 0.25. This one we already did with kubectl. This one we did with kubectl. We don't need Slack right now. Flagger takes a Kubernetes deployment and optionally a horizontal pod autoscaler, then creates a series of objects, deployments, cluster IP services, Canary ingresses. There is a load tester. We have an ingress. Let's look at this custom resource. Okay, I'm going to use this CRD. A custom resource is just like any other YAML, like a deployment or a service, but it can it's defined by somebody else, not the Kubernetes upstream people. It's basically a place where you can hook in and extend your Kubernetes with various features. The controller will look at these. So this is Canary definition.yaml. Good. Namespace should be default is fine. Podinfo. Okay, let's leave it like that. Deployment reference. The deployment is a service. Ingress. It's called a service. I don't have a horizontal pod autoscaler, so I delete this. Maximum time in seconds for the Canary deployment to make progress before. Okay, 60 is fine. Canary port. Container port, yes. That's it's port 80. Every 10 seconds. I don't have this, or do I? I don't have this. It can do a load test, maybe. Interesting. Optional for now. I don't have any metrics exposed. Maybe I will use their example. Nope, I don't have this guy. Nope. So is there a There are artifacts. Thank you for including a sample application. Artifacts, nginx. Deployment. Podinfo. Podinfo D. There's Liveness Pro, Readiness Pro. All right, I'm gonna use this. This is so much better than my example. I will not use the horizontal pod autoscaler. So I don't know what's this double forward slash, but it's probably something what GitHub can understand. Expecting a directory. Yes. K. What's a K? Flagger artifacts nginx. All right, I'm just gonna steal this. And I'm not saving this Canary definition. I am yes, it's creating. Does it have an ingress? No, this is only the deployment. I'm not using the HPA autoscaler. Now adding the ingress. Where is the service, by the way? fubar.com. This will not work without the service, or does it? Just applying again. Oh, come on. What happens now if I go to fubar.com? It was this one, right? Okay, it's missing a service. I think it's missing this one. Let's name it Podinfo port. And namespace is test. How about now? Podinfo. Greetings from Podinfo, served by ping. Nice. Okay, this is a nice little test service. What else can it do? Okay, nice. All the things. Oh, this is versions, right? Nice. This is really a nice default app. Commit and version. I'm gonna like this. Okay. So we have and now the Canary. Did I already apply it or not? I probably not. Let's copy it over again. Podinfo. I don't have the autoscaler. I don't have the load tester for now. And do I have some metrics by now? Targets. Pods. This one is running. I recognize the port. So it should have some request. Metrics. What kind of metrics do you expose? Just okay, HTTP request duration. All right, so but maybe there are some rules here. No. Okay, I am not sure where this metric will be created because it's not part of the Prometheus database right now, but let's see how it goes without it. Okay, of course I named it differently. Canary definition. It created this. So kubectl get CRD. How do I? Maybe just Canary. Nice. So this is a CRD. The name is Canary. And status initialized, wait 0. Last transition time. Okay, and what about all the ingresses? Still just one ingress. And what does the controller say? The controller recognizes that there's a CRD. All right. What next? So, okay, so it should have generated these services. Because, okay, so there is this service which was there originally. No, it wasn't there originally. Okay, wait. So I created that manually, and I shouldn't have, because once the CRD is there, Flagger will create the service. And also we'll create two services, two pointers basically. Primary will point here, and the Canary will... Okay, this makes a lot of sense, although I should follow tutorials more closely, I should say. So how about my deployment? I delete this service because I don't need it. And oh no, I am going to keep it. I'm going to, instead of apply, I'm going to delete everything. Now delete the service definition and apply it again. Oh, I have a Podinfo primary? Now I am confused. I did not create that primary thing. Oh, and I have the services for 3 minutes. Okay, I just missed it. Good. So why do I have a primary and then my own thing? Did I do something wrong? So I apply the deployment, that's fine. I apply the ingress, that's fine too, and I apply the CRD. Anyways, so I have this. Oh yeah, okay, so I have this deployment too. Okay, so there is this deployment which I created, the ingress I created, the CRD I created. Then it created a primary deployment for whatever reason. It created 3 services and an ingress. So it created these services and then ingress. It did not create the ingress. Why it didn't create the ingress? I don't have an ingress for the Canary. But at least I do have the ingress here, right? I have it. So this is the primary. What to do now? I need that Canary ingress, don't I? Let's continue. Okay, so this is how I trigger. So instead of this set images not how I roll, I use my CI to update version numbers and just reapply this deployment. And once I apply it, I should describe this. Okay, I'm gonna watch the canaries. I'm gonna watch the canaries right up here. All right, let's apply. Creating the new version. The canary is progressing. Amazing. This one is running, but okay, now it's 1/1, and this one is terminating. Terminating already. Interesting, because the weight is only 5. I expected it to be running for until the full progression. But this primary is running, so maybe that's good. So what is happening here? The version is still 1.7, maybe because I'm not seeing the canary. And when does it progress further? Every 60 seconds, right? Or yes, it's a bit slow for my test, so it goes. No, it's actually faster than that. Maybe my CRD can tell. Okay, so it should progress every 10 seconds. But it's not progressing further. Okay, I'm gonna describe. Canary Podinfo namespace test. So, new revision detected. Scaling up Podinfo test. So something is not working properly here, I think. I might just start again, clear everything. Maybe the pods I created were a little bit off, or the service or something. It also bothers me that this request success rate, where does it come from? Because how can it evaluate my canary if there's nothing to check? So maybe I'm gonna pursue this this metric, because it should be somewhere. Let's just finish this. Great, I can use my own metrics. That's brilliant. I am not fully aware of the terminology and everything, so maybe I should read the concepts page as well. It can do A/B testing. Oh, this is some advanced use cases. Okay, so where does this come from? This metric. Graph request success rate. I think I'm gonna search for this string in the GitHub repo. All right, this test was very promising. The controller was doing some things. It did not progress over 5%. I am missing some of the entities from my Kubernetes deployment. And the metric is missing. So I think I'm gonna look further and maybe retry this exercise, and then I'm gonna come back with a summary and also probably a working demo. Right, and yeah, stay tuned. All right, I think I cracked the problem. First, I was concerned about the metric request success rate, which was nowhere to be found. And it turns out it's a built-in abstraction inside Flagger. So I searched in the source code for request success rate, and in the nginx Go file, basically it resolves to this Prometheus query, which is basically a division of the request count, which is not 500, so basically successful requests, divided by all the requests. So it's really a success rate. So that's good, even though I didn't think we have this metric. We do, because Flagger resolves this to this Prometheus query. Could have been more transparent, including it in the YAML, but I understand that it would inflate the YAML quite substantially. And I also had a problem with the Canary not progressing over 5%, and I submitted an issue for Flagger, and the Flagger people were very nice and pointed out that I missed one entry in my Canary deployment or the Flagger setup. Basically, it was I had to set the provider to nginx, because I will set Flagger up again, and you will see that the default is the Kubernetes provider, which is I still don't know what it is, but in the path I followed, basically set it up as Kubernetes and not nginx. So I cleared up my K3s. So right now there are only the K3s pods and an nginx Ingress Controller, and I port forward the Ingress Controller. And going back to the installation guide, I will use this Kustomize. I learned what -k is Kustomize. This Kustomize version of Flagger, and I'm going to just apply it as is. I have to export the kubeconfig, and it will create Flagger, a namespace, and so on, and also the Flagger Prometheus, which I'm also going to port forward. Port 1990 is perfect. So this Prometheus is running, and if I think I forgot here the export as well. All right, so if we visit localhost 19, oh, that's not a port. Yes, so Prometheus is running. The next step was, yeah, so just looking at this this Kustomize source code. And I look at maybe the patch YAML. Yeah, the mesh provider is Kubernetes here. And the documentation also suggests that later on I can overwrite the default in the Canary resource definition. So spec provider nginx. And I also created the CRD definition as well. And here I am getting the canaries in all the namespaces. There are no canaries yet, but soon there will be some. All right, so I think I installed Flagger. So going back to the nginx Canary deployments page. Let's create the namespace. It's created, and I'm going to use the provided deployment. It's very nice. This repo variable is not really documented in this page, but I found it in the how it works guide. In the load testing section, it's a bit left and right, but I will use the load tester as well. So I will come back to that very soon. So I have the repo exported, and I'm going to install the deployment, which created the Podinfo service. And this guide recommends to install the load tester as well. Now I won't install this with Helm, but instead I'm going to install this with the kubectl apply. I like that Flagger includes everything, really. There's a very nice test service, this Podinfo service. The load tester application was working in my offline tests as well. Very nice. So I am quite happy how Flagger is packaged. You can see some copy and pasting in documentation, and Helm and Istio is getting prime time, I can tell you that. But still, after a little bit of trial and error, I was able to set it up. All right, so the load tester is running, Podinfo is running, Flagger is installed. And this was the load tester. And it was asking me to set up the Ingress separately because I used their deployment. I created this Ingress. fubar.com, we know this, and it's pointing to this Podinfo service. So if I do apply, this is Podinfo Ingress. Ingress is created, getting all the ingresses. Now we have Podinfo. So if I go to fubar.com, I think I have a browser window with that. fubar.com/metrics. Okay, it's unavailable right now. Oh yes, because the service is not part. So the Kubernetes service entity was not part either this Ingress YAML nor the deployment. So right now, the service is not reachable, but I will just go one step further and it will be fine. So the Canary custom resource, this is the Canary definition. Because I applied all these, it will create a bunch of things. It will create the Podinfo service, what we were missing right now, what we are missing right now. And it also creates Canary and primary and all kinds of services. Basically, when we roll out the Canary, all it will do is we'll play around with the services deployments and ingresses. So how about just creating the Canary definition? The only change since last time is that I added the provider nginx. This was the problematic part, and I included this load tester webhook. because Flagger is very nice. Basically, it tells it gives you this load tester and possibilities to call the load tester for situations where your service is not under usage or heavy usage. So maybe you are deploying at I don't know 6 in the morning or at a period where there is no load. For the Canary criteria and error ratio to make sense, it's very nice to have some load on the service, and this one is actually generating the load. So I included the webhook and pointed at my service. So right now I'm going to apply this Canary definition or CRD, and now it is initializing. And in the documentation, we have seen that a bunch of things will be created. So instead of creating the service ourselves, Flagger is going to take charge of the services and the deployments as well, because the Podinfo deployment, what we had, is vanished, and instead there is the primary service now once it's initialized. And if we are getting the ingresses, now we have the Canary ingress as well. Now it's a little bit unusual, or you know, up until this point I was in charge of my deployments, my services, and my ingresses. And going forward, some changes in my workflow and mindset is needed, because it kind of makes sense what Flagger is doing with the deployments and all the things, but still it gives some automation or magic factor, and I have to reconcile my models in my head. What is that I control and what is that the deployment tool controls. All right, so this is initialized. We have all these guys, and there is one more thing I want to look at. Maybe the nginx HTTP requests total on the chart. So it seems like the load tester is running. And if the only odd thing is that I haven't scaled my service yet. Still, it generates load, so something to look up there. What is interesting for me is, I think, ingress equals podinfo, perhaps. No, there is no podinfo. Yeah, we have the pods, 503s, 200s. Maybe this is only the health check, so maybe what I just said earlier is not true, that this is the load tester, but we have some requests going on, and my service should run. Yes, it is running, and it's the blue 170. Now I'm going to trigger a promotion. I'm going to use the set image. I would just reapply the YAML, but let's stick to this guide right now. And the moment I'm going to do this, things will kick off. So a new Podinfo deployment is created with the 171 version. The primary is still 170, and the Canary is progressing to 5%, and it's gonna go to 10% in 5 more seconds. Crossing fingers. Yes, it's there. Right now, I'm going to just look at the service. What do we see? Yes, so this one is sometimes blue, sometimes green. It's more blue because it's very few percentage that it's rolled out to. We are at 20%. Maybe I should refresh. Okay, yes. So now it's green and blue, green and blue. that's basically what we expected. 25%, and if we describe the Canary Podinfo in the test namespace, we see those weights being increased as well. And once it's reaching 50%, it will conclude the rollout, and we'll do a finalizing stage where it will create a new primary with the new version, tear down the old primary and this Canary pod. So basically this is the Canary, it's just not named like Canary. Yes, it's 50%, and it's not easily visible, but it's tearing down things. So the new primary is only 14 seconds old, and the old Canary is still running, not for long. It's being shut down, and it says everything is done. So it was rolled out, and we should see 171. Yes, we do see that. So that was a Canary deploy. It wasn't too bad, and there are some very nice extra things or additional things in Flagger, like the metrics. It provides some metrics like a Canary weight with different labels, Canary status, total, and so on. So these are just as a retrospect. We could look. Maybe I have to refresh to reload all the metric names. Maybe okay. So how about, I think this heavier increase in the in this line was the load tester. This was probably the health check. So Flagger, Canary total. We had one Canary with the labels. The application is Flagger, blah blah blah. And I'm interested about the weights, how they changed over time. Now, this one is the Canary. This one is the primary. Yes, this one is the primary. So it's interesting to see that first the Canary weight is increased. Meanwhile, the primary service is decreased. And at the point of finalization, things are switched. The Canary is thrown away, and a new primary was created. So that's why the primary goes down and up, and then the Canary goes up and back down. So I think semantically, this might not be what one would expect, but it's understandable after you have seen what was going on during deployment. So we looked at monitoring, and I want to show you one more thing, or a couple of more things. In the how it works section, there is a description about the webhooks. And it's kind of nice how many different things you can achieve with a webhook. So there is a confirm rollout hook, which is before scaling up the Canary deployment. So this is like a manual approval flow, pretty nice. Pre-rollout is before the Canary getting any routing traffic. So basically you can do some tests on the Canary before it gets any traffic. This one is the rollout hook is in every iteration of the Canary. When you increase the weight, you can do some test or load test or whatnot. And the post-rollout hook is once everything is done, you could log or notify or do something custom. And I like that with just a single mechanism, you can achieve so many different things. It can also do blue-green deployment, and it was a little bit retrofitted to the Canary world as I saw it, because you still define the Canary analysis parameters, and it doesn't come off like very easily. Like you can't really tell that this is a blue-green deployment. But basically, with the a pre-rollout hook, this is what makes it this a blue-green. Basically, before I think it's summarized down here. When a new version is detected, Flagger scale up the green version for tests, and once the tests are passing, Flagger would validate, or Flagger would just switch the deployments. So it's a blue-green in a sense that you have two sets of deployments. You have an automated test in the new set of deployment, in the new deployment, and when everything is fine, it will do the switch. It's just hiding behind the Canary semantics. If something I would change in Flagger is that I would make the blue-green more obvious, more semantically correct. But I'm sure this is just early days for Flagger. All right, so what else? What I wanted to show or talk about? Not much, I think. So my overall impression of Flagger was very nice for a couple of reasons. One is that the CRD and its concise definition of the deployment strategy is a very nice way to define your deployment strategy. And you could define many different things. You could hide a blue-green inside this, but I would be more happy, or would be happier if there would be like a blue-green YAML bit here. Or but other than that, I like the format. I like the controller approach, the control loop. It's quite clear what's going on. The CRD gives you a good transparency with the status, what is going on, and what gives you the even more transparency is these metrics. I like this a lot. So you could create a dashboard and see how your service is being rolled out. I have to get used to the fact that the things that I deploy are only the deployment and the ingress, and then it takes control of the services. Up until this point, I was making my own services. So this is a little bit something to get used to, or maybe there is a better way to do it. I have not haven't thought about this. For example, just as a test, I'm going to just maybe deploy my deployment one more time and see what happens. Yeah, but that's great. Webhooks were amazing, and it's just a nice little system to do your deployments with. I still have to figure out how to make it work with like Weave Flux and with my deployment tools, but it seems like it fits quite nicely. So that was Flagger, and I'm pretty sure I'm going to try to use it in one of my projects. So yep, that's that, and thanks for watching. Bye bye.